Welcome to the second part of the introduction to remote sensing. In the first part, I introduced us to what remote sensing is all about and the challenges of in-situ weather observations and how remote sensing can step in to address some of these challenges. Let's go and into the second part. We have the various ways in which we can apply remote sensing, either with the use of the smartphone camera or with the Earth observation. When you use the smartphone camera, it helps to take high resolution pictures, and then in the modern smartphone cameras have the feature called the Edge AI processing, and then it can carry out real-time geotagging. When you carry out remote sensing processes or when you observe the Earth from satellite, it affords you the ability to carry out multispectral imaging, environmental monitoring, and global tracking. Next up, we shall look at the elements of the remote sensing process. And to achieve that or to know that, just know the alphabet A, B, C, D, E, F, G, H. That makes how many? 8. That is the first step of remote sensing, or the first element of remote sensing, which is energy from the sun, which is the source. The remote sensing, don't forget, makes use of reflected or emitted energy. So that the energy comes from the source, and in this case, or in oftentimes, it comes from the sun. The next element of the remote sensing process is the interaction with the atmosphere. The energy travels through the atmosphere. The next element or the next step is interaction with the target. After the energy from the sun or from the source travels through the atmosphere, it interacts with the target, and in many cases, with the Earth's surface, if you are to observe the Earth's surface. And the next element or the next step is reflection and scattering. This energy is reflected or scattered in various directions, and it is moved towards the sensor, which is the next step. The sensor detects the reflected energy. The sensor detects the reflected energy. And after reflecting this energy, it transmits it, which is F. It transmits it from the satellite to the ground station. And after this data is transmitted to the ground station, we have the next stage called reception and processing. That is, the data is received, processed, and converted into usable information. Usable information. And the last step or the last stage is interpretation and application. This information is analyzed and applied for decision making. Let's have a quick test. What does A stand for? What does B stand for? How about C? Do you know what C is? Do you know what D is? How about E? Can you tell me what E is all about? Then the next stage is F. Do you know what S stands for? Do you know what G stands for? And the last stage, the last element is H. Can you tell me what H is all about? Have you tried this bit of test? Let's have the answer once again. We said A is the energy from the sun. B is when the energy travels through the atmosphere. C is when the energy interacts with the Earth's surface. D is when the energy is reflected and scattered towards the sensor. E is when the sensors detect the satellites, when the sensors, that is the satellite, detect the reflected energy. F is when the data is transmitted from the satellite to the ground station. And G is when the data is received, processed, and converted into usable information. And H is the last stage, which is interpretation and application. The information is analyzed and applied for decision making. Next up, we shall move into the types of remote sensing. There are two major types of remote sensing. We have the active remote sensing and the passive remote sensing. The active remote sensing includes or has to do with the emission of the energy towards the target. Okay, this means that the sensor emits its own energy towards the target, and it measures the returned signal, which is also known as the echo. It works both day and night and in all weather. On the other hand, we have the passive energy. The passive energy does not produce its own energy or does not emit its own energy, unlike the active energy. It uses the energy from another source, and in many cases, it uses the natural energy from the sun. It measures reflected or emitted energy, and it oftentimes depends on daylight and weather conditions. And here are some examples of active remote sensing. We have the synthetic aperture radar, which uses microwaves to produce high resolution images both day and night through clouds. We also have the LiDAR, the light detection and ranging, that uses laser pulses to measure distance and create three-dimensional elevation maps. And there is the radar altimeter that measures the distance between the sensor and the Earth's surface. The examples of passive remote sensing include optical imagery, which uses visible and near-infrared light to capture images of the Earth's surface. We also have the thermal infrared sensors that detects natural heat. What are the benefits of remote sensing? I will highlight some of them. The first benefit is that it enables the coverage of large areas. Remote sensing helps to monitor vast and inaccessible areas quickly and efficiently. Remember, remote sensing is about observation from a distance, observation especially in remote areas. Remote sensing is time and cost effective. It reduces field work, time, and operational costs. Remote sensing enables monitoring of changes and trends over time. Remote sensing helps to collect data from remote areas, hazardous areas, or difficult terrains. Remote sensing also helps in providing reliable, objective, and quantifiable information. Remote sensing helps to capture data in multiple wavelengths beyond the human vision. Remote sensing helps adequately in providing timely insights for planning, management, and policy making. Lastly, remote sensing helps in early detection, monitoring, and assessment of natural disasters. In conclusion, remote sensing helps us understand the weather, climate, and environment better. It supports climate research, agriculture, disaster management, and urban planning. Advances in artificial intelligence and satellites are improving observation capabilities thanks to remote sensing. As a matter of fact, the future of the Earth observation is becoming smarter. So, if this lesson has helped you to understand this topic better, do well to like and share this video. Share it to as many platforms as possible so that others can watch and learn. If you have comments, if you have questions or any remark, drop it in the comment section below. I will make sure to read each of it and to provide a response. Don't forget to subscribe and hit the notification button